Technical Corner.
So welcome to this week's Technical Corner. I'm with Gio today, and in the usual style we're going to be looking at 8 videos in the next 10 minutes, what we've been up to, where we've been, and some of the interesting highlights. First of which we start with the Brother machine. I shot this video recently at EMO. This is the FEEDIO with the attachment of a FEEDIO, and the FEEDIO, as it aptly says, actually feeds the machine. Now, everybody knows that the FEEDIO machining centres are high-speed machines from Brother and Whitehouse Machine Tools in the UK. Now, with this automation system added to the machine, you can see you can get significant improvements in your productivity. Here we have a 2-axis table on the machining centre, but the key to this is that part there, really, isn't it, Gio? What did you take from this video?
I thought the automation is absolutely fantastic. The complexity of the part and how the part can be presented to the inlet conveyor. It hasn't got to be in a specific position. The robot can sense where the component is and load it into the machine accordingly. And then you've also got the outlet conveyor.
And it's quite a small system as well. When you look at the fact that here it's quite neat and compact. And I think what I like as well is you've got the outlet feed directly underneath, so the operator can load parts, but at the same time he can be taking parts off the base conveyor.
Small footprint.
Small footprint.
Fantastic technology.
Great
solution.
High-speed machine, and these are irregular castings here. So if you've got irregular shapes, this sort of solution could be ideal for you for high-speed productive machining.
Very impressed.
The second piece we're going to look at here, Gio, and I know you know a little bit more about this than me, is a solution from NCMT for work holding. Give us a little bit more detail.
The blue photon. The blue photon, in my opinion, technically I don't know a lot about it, Paul, but I can see some great applications for the blue photon. It's new technology, new innovative technology from NCMT, and hopefully there'll be a bit of a clip on it coming up soon, Paul, but you put adhesive onto little gripper pads, so you're at any kind of contour or bottom contour you can hold. So if you're want to hold on a radius, you can hold on the bottom of a radius. Or for me, it's for here we go, Paul. So you can present the grippers here. But say for example, for me, it's application specific, and a component that you could not hold in any other way. Say for example, a 4-legged chair. If that was a component with stems or an aerospace component with stems, you can put the adhesive under the 4 legs, clamp the part, pull down.
Can you imagine it being secure though? I mean, it'd have to be, it's a bit like super glue, Gorilla Tape or whatever.
Yeah, it's pull down force, Paul. So you're pulling the component down. If you were trying to hold it externally with external mechanical gripping, you'd crush the part. There's no other way to hold it. So for them kind of applications, perfect.
The chair is a good analogy, or a good part to talk about, because imagine if Joe was sitting on his chair and he broke his legs, he might need a new one.
In the same breath, Paul, just the clamping force, I believe, is quite significant as well. It can hold billets, but for me, perfect for that kind of application.
For difficult parts. Now, next video, Hainbuch. This is a really innovative system as well. Automation again, it seems to be a bit of a theme at the moment, doesn't it? But we shot this recently at the EMO show as well. And this is about a robot actually loading the collets into a collet chuck on a machine tool. I mean, traditionally you would load a collet with a gun from Heinberg, but here the robot is doing everything, and you have your collets actually laid out here, so you can change them throughout the production process. You've come across this before, haven't you?
Yeah, I've seen videos of this, and I love it because it's just simple. It works and it's simple. You're utilising the Heinbuch collet, and so simplicity through design.
And also with this as well, they changed the end stop. So if you've got different bar lengths, you can actually change the end stop with the automation as well. And you can see here, this was actually in action on a DMG machine, but I know they have rolled this out into the marketplace already. So if you want to change the collets without the intervention of an operator, then this could be an ideal solution, couldn't it?
Perfect.
On to the next video here, Leader from Leader CNC. We both visited this. I'm interested in your take on this machine tool because we reviewed it, and it is a machine that's available from stock. This is a DMC machine. It's a twin spindle machine. Each spindle has a turret, but instead of you having the normal traditional spindles that oppose each other, these are actually facing you. And you kind of try and explore what's the advantage of using a machine in this layout. I know you've got a few reasons why you think you would, but interestingly and fundamentally, we've got 2 spindles, a turret on each. This is purely about turning. There's no milling on this, and there's an in feed and an out feed. But why do you think you'd use a solution like this, Gio?
It's for very high volume turning work in a small footprint as well. Perfect for the automotive industry. The layout of this machine once you look at it in a bit more detail, it's self-explanatory. So on the left-hand side of the machine, you can't really see it, just gone out of focus now. You've got a stacker system, an inlet. The gantry picks up the component from the left-hand side of the machine, loads it into spindle 1, and then from spindle 1 it can be loaded into spindle 2, and then from spindle 2 to the outlet on the right-hand side of the machine, swarf evacuation through the middle of the machine and out of the back. So all of this with the automation on top of the machine effectively, very small footprint, very productive machine, dedicated to one particular part. You won't be doing lots of different variants.
Correct, and as I said earlier, it's all about turning here, so you could be talking about brake discs or parts of the automotive industry.
Yeah,
not often you see one of these machines in stock, so it is available, so if the application's right, could be delivered very, very quickly. Now, as we move on to the fifth video here, Mills CNC, again, we both visited Mills recently. The Strokes of Genius live event actually takes place on October the 18th and 19th. I went along and had a look at a few of the highlights, equally did yourself. One of the things that Tony was telling me about was the new Siemens control on the D&M range of machine tools. Now, the D&M machining centres had traditionally come into the market with Fanuc controls and Heinberg controls, and they hadn't yet put the Siemens control on the machine, but now it is available. So if you're used to Siemens, well, the beauty is now whether you're buying a D&M machining centre, you can have Fanuc, Heinberg or Siemens. But we also looked at the 5-axis machines, and you were interested in those too, weren't you?
Yeah, there are two different types of 5-axis machine that are going to be at the event. There's a 4+1 and a full simultaneous, and I think it just illustrates the marketplace. I mean, it's a big selling machine now, the 5-axis machine, and it just illustrates not everybody needs full simultaneous, Paul. So you've got both options.
And that was 5-axis. When you went back, you also looked at the new Puma, didn't you?
Yeah, the new Puma 2600 SY Mark II. So this is a new revamped version of the Puma, which is already one of the best-selling machines from Mills, and lots of big benefits.
I think there's more power on the machine. There's a few more, features that have
productive
been introduced.
Benefits that we're going to find out at the event.
And you can't forget the RoboJob, because that was an automation
system.
Yeah,
RoboJob, again on the automation theme that we've been touching on a lot, with two best-centric grippers all interfaced with the machine. So I'm looking forward to see that in action.
So that's October the 18th and 19th.
And before I forget, the prime turn from Sandvik,
yes.
New turning technology as well.
Seminars. They've got seminars on as well. So it's the 18th and 19th. You can register for that event through MTDCNC as well. Also, this is an interesting video. You're an expert in the work holding field. Bit of a strong word, but I'm sure you'll agree. Micron Work Holding are now supplying, and have been for a while, the VB Dock Lok solution, which is a 0-point clamping system. I spoke to Matt Janess here. The interesting thing about this is the product hasn't changed, other than the fact that it's now using pneumatics rather than hydraulics. So this 0-point clamping system is a way of accurately securing parts, isn't it? But what's the difference between having hydraulic and pneumatic? Is there?
For this particular work holder, I don't think there's really it's preference really. I think hydraulics obviously you need all of the hydraulics, and it can be dirty. With the air, you can just simply use shop air, so it is a lot cleaner. And really, essentially, what this kind of work holding is for repeatability, fast changeovers. You can do low volume work and high volume work, so you could fixture up with 0-point repeatability, low volume or high volume.
But with the pneumatics, it's actually the air. You're not feeding the air in to secure it. It's when you release the air that it actually gives it security. But I don't know whether you saw that.
I'm not familiar with that system, Paul, but I can talk about why the application and why 0-point is so essential now, and why a lot of people are using 0-point for lots of different applications. It's quite very versatile system. Yeah,
a good seller for them as well. The next video, this is an interesting one for work holding as well. Again, we've talked a lot about automation. A couple of videos here about work holding. This being another one. This pin system on this vise from Hyfore here. How does that work? I mean, to me, I can see why you'd use it, because you've got irregular shapes and castings. Is it a secure way of clamping?
I'm not sure, Paul. I've not seen this work holding. I can certainly see the benefits of that work holding for irregular shaped castings, for example. I'm not sure if you can increase or decrease the clamping force, which is important if you're doing solid parts or thin-walled components. You obviously don't want to crush them. But essentially, again, it's one of them work holding where if there's no other way to hold that component, it's a perfect solution.
Yeah.
There's a lot more I'd like to find out about that
and I think you're right. And I mean, I did speak, and we're going back a little while now when I had a conversation about this particular vice, but it is innovative. I wanted to show it again because it's very different. I know they've sold a lot of them, a popular solution. Okay, so as we move on to our final piece for this week, Gio, an event that happened at the AMRC talking about max machining from OpenMIND, or Hypermill from OpenMIND. Max machining is about reducing cycle times, it's about metal removal, and in some applications they're talking about removing or reducing cycle times by 90%. Where does it fit?
I think there's definitely a place for it for components with deep pockets where there's large plane areas. Because when you're finishing them with a traditional bull nose cutters, you're only stepping down in 0.4 increments. But with this new tool, a new software from OpenMIND and quality fifth axis simultaneous machining, you can go down to 6 mil step overs. So you can reduce the cycle time by up to 90%, which is
that roughing and finishing? Where's the difference?
There's a different cycle or strategy for the roughing, which is similar. And again, I think there's large gains in productivity through the roughing cycle. Again, Paul, at the seminar it focused more on the finishing than the roughing, and it's something I would like to investigate a little bit further, the roughing strategy, because that's just as important.
Adrian mentioned, and I want to finish on this piece, Adrian mentioned that max machining is going to be as big as 5-axis machining. Do you agree with that?
Not sure. I need to look into this a little bit more.
But what I can say is that the uptake on this type of technology, the amount of events we're seeing focusing on this, there must be a big market for it.
It's massive. I mean, some of the savings are huge, and for the right applications, some of the components we see, fantastic. I mean, to save 90% cycle time is, if you've got the right parts, amazing. So, any material as well, Paul.
Yeah. As usual, been a pleasure. This has been MTDCNC's technical update for this week.